Hello and welcome to the 2020 HSC Maths Advanced paper. In this video I'm going to be covering the multiple choice questions for this exam and the first 10 short answer responses as well. If there are any questions that you feel don't get properly answered, please feel free to ask for a further explanation. I'll do my best to get to those questions, but hopefully this will suffice. So let's just get straight into the first questions. So for question 1, we're basically asked to find the domain of this function here. And in order to do that, we just have to consider what numbers we can actually square root. Now, unless we're doing extension 2, we know that if we want to square root a number, it either has to be 0 or it has to be positive. We can write that as an inequality in saying that the thing under the square root sign, which is 2x minus 3, has to be greater than or equal to 0. If we add 3 to both sides, this becomes 2x greater than 3, and then if we just divide by 2, that's x bigger or equal to 3 over 2. So that option's D, so we'll circle that, and that's the first question. So now we'll move on to question 2, which is fairly straightforward as well. It says the function f of x equals x cubed is transformed to g of x equals x minus 2 cubed plus 5 by a horizontal translation of 2 units followed by a vertical translation of 5 units. And then we're asked which row of the table shows the directions of the translations. Now the easiest part for this question is to say, well, we're told that we have a plus 5 here, and there's no real trick with the vertical translation. If it's a plus, it means it gets moved up. So what we can do straight away is we can cross out option C and option D. Now this is just a simple question from year 11. Essentially what happens is if we have a negative inside here, which is x minus 2 or cubed, that means our function actually gets moved over to the right, which means option B is the correct answer. Now I've included the formula from the formula sheet here, which tells us that a z-score is equal to the raw mark, or the raw score, minus the mean score divided by the standard deviation. For this question, we're just going to have to apply this formula and see which subject has the highest z-score. So firstly, we'll compute this for French. I'll just denote this z subscript f, and that'll be equal to x, which is 82, minus the mean, 70, divided by 8. And if we compute that however you like, we'll end up with 1.5. Now for commerce, ZC, that's equal to 80 minus 65 over 5, which is 3. And finally music, 74 minus 50 over 12, which equals 2. So from this, we can see that the highest z-score is commerce here, and the lowest one is French. So we go to our options and we see the strongest subject, commerce, can either be A or D. So we'll cross out B and C. And we see weaker subject is French, so we're going to get rid of D, meaning A is our correct option. Okay, so now question 4. This is our first taste of Year 12 calculus for this paper. And all we're asked to do is to find the integral of E plus e to the power of 3x with respect to x. Now this question, I believe, tripped up a lot of students in the actual exam solely because of this e. They thought that represented the exponential function, when in fact all it represented was the number e, which is about 2.71 ... So in terms of that, it's just a constant, which means when we integrate it, we're just going to add an x onto it. So if we compute this now, we just have ex, and we follow our rule for integration where we take 1 over the power, so 1 over 3, times e to the 3x, and then we add a constant. So if we wanted to check that this answer was correct, what we can do is we can take the derivative of what we've calculated, and we should get what we started with. So if we do that, we'll see that we'll get rid of the x, so it'll become e plus 3 times 1/3 e to the 3x, and the derivative of a constant is 0, so we just get left with that, which equals e plus e to the 3x. So that means what we calculated was correct, so our answer is B. Now for question 5. This one involves a little bit of thinking, in that we're not given a real direct number, so we can't just try and plot points and draw the graph. The first thing we notice is the negative sign outside the front of x squared. Now that means we have a concave down parabola. So immediately what we can do is we can cross out A and we can cross out B. as these are both concave up parabolas. Now, the second thing we notice is that we're told b is greater than 0, so that means b is a positive number. So here's what I would do. I would say let b equal 1. The reason I do this is, as you can see, the numbers here are quite small in our graph. It's probably a safe assumption that this is actually the graph with b equals 1, but we're just going to assume that because it says b is positive, and we want to keep a nice and low number. So then what we'd have is we'd have y equals minus x squared plus x plus 1. My next step is actually I'm going to sub in x equals minus 1 into this expression. And that's going to tell me that y equals minus negative 1 squared plus negative 1 plus 1. And that evaluates to just 1. So, because b is positive, we've assumed it's 1, and we subbed in minus 1, we should have a positive number. If we look at our graphs, we can see minus 1's about there, and about there. We know we should have a positive number, but if we look at c, we're down here somewhere, which is negative. So we can cross c out, and we're left with d, which is roughly 1, so our answer is D. Okay, so now for question 6, we're asked to find the range of the function y equals 5 plus 2 cosine 3x. Okay, so now for question 6, we're asked to find the range of the function y equals 5 plus 2 cosine 3x. In order to do this, we're going to consider cosine 3x by itself. So if we just write cos 3x here, we know a fact about cosine in that it is always between minus 1 and 1. Now, with this inequality, we can just multiply every term by 2. What this will give us is 2 cosine 3x is greater than or equal to minus 2 and is less than 2. We can now add 5 to each term. So 5 minus 2 is less than 5 plus 2 cosine 3x, which is less than 5 plus 2. So we get 5 plus 2 cosine 3x is greater than or equal to 3, which is less than or equal to 7. So our answer is B. Now for question 7, we're asked to find the value of this integral of f of x between 12 and 0. This question is really trying to differentiate the students who perceive integrals as just the area under the curve and those who understand the ramifications if the curve is underneath the x-axis. What I mean by that is that the area under the curve is only equal to the integral when your curve is above the x-axis. So we can see for this part here, this whole part above, that is true. However, for this other part, which I'll put in green down here, that's actually going to subtract from our integral. So what our integral is actually going to be, it's going to be the area under the red part. So I'll put area in red, and then I'll put it minus the area in green. If I now just remove these markings so we can see the actual shapes which our curve is made of, we can see we have a rectangle here, we have a semicircle, we have a triangle, and we have another triangle here. So the first thing we can do is we can calculate the area of the rectangle and the semicircle. For the rectangle, all we're going to do is we can see that it has a height of 3 and it has a width of 8. So we can calculate the area of the rectangle, AR, equals 3 times 8 equals 24. We can now find the area of the semicircle, as we can see that it has a diameter of 4. That means its radius is 2, and we can find the area, SC, will be a half times pi r squared, which is a half times pi times 2 squared, which is going to be 2 pi. Now, the last thing we see is that this triangle here has a height of 3 and a base of 2, which is exactly the same as this triangle here, which has a height of 3 and a base of 2. That means the area of these two are going to be the same. And as we said, our integral is going to be the top area minus the bottom area. These two are going to have no effect whatsoever on our calculation. So we actually have our final answer already. We just have to add these two things together. So we say the integral from 0 to 12 f of x dx is equal to 24, which is the area of the rectangle, plus 2 pi, which is the area of the semicircle. And that answer is A. Okay, so the first thing to notice with this graph is that it's shaped downwards. This means it has a negative concavity, which means its second derivative at x equals 1 is negative. So what we can do is we can look at options C and D, which say that the second derivative at 1 is greater than 0, which is just wrong, so we can cross those out. Now we have to determine whether A or B is the correct option. Now we just have to determine whether A or B is the correct option. In order to do this, we're going to have to compare the value of the function at x equals 1 and the value of the first derivative at x equals 1. To see what the value of the function is, we can just approximate roughly where this is on the y-axis. We can see that it's clearly above 1, which is roughly there on our graph, and it's less than 2, so it's somewhere between 1 and 2. Now what we're going to do is draw a tangent line at x equals 1. This is going to help us, as we know that the value of the gradient of the tangent at a point is just the value of the first derivative at that point. So if we draw our line, we get something like that. What we can then do is we can grab our line and we can just move it to the origin. If we then just draw a little box here, what we can then see is that this tangent line passes through the point 1, 1. In order for that to happen, as well as it going through the origin, it must have a gradient of 1. So as a rough approximation, we can say f prime of 1 equals 1. However, before we said that f of 1 was greater than 1. So we can clearly see that f of 1 is bigger than f prime of 1. If we then look at our options, we are left with the conclusion that A is the solution to this problem. Okay, now for question 9. This question is definitely the most challenging question up until this point of the exam, so I'll just read it out. Suppose the weight of melons is normally distributed with a mean of mu and a standard deviation of sigma. A melon has a weight below the lower quartile of the distribution, but not in the bottom 10% of the distribution. Which of the following most accurately represents the region in which the weight of this melon lies? In order to do this question, it's best if we consult the diagram given to us on the formula sheet. Now the reason I do this is so we can see roughly where the bottom 10% of the distribution is. From this we can see 95% is between 2 and negative 2, which means we have 5% left over, 2.5% of which goes over here and below, and the other goes above 2. We can hence deduce roughly that 10% of the distribution will be somewhere between negative 1 and negative 2, more skewed towards negative 1. So now back to our diagrams, we can see that the 10% of the distribution is roughly along this line here. Now straight away from this, we actually have our solution. The reason is, for A, B and D, we can see that our melon has a chance of actually lying in the region which is in the bottom 10%. So, logically, the only possible answer can be C, and that's the answer. On to question 10, we encounter a problem which is quite difficult, probably more so than question 9. The question says, the graph shows two functions, y equals f of x and y equals g of x. We now define h of x as f of g of x. And we're asked how many stationary points does y equals h of x have for x is between 1 and 5. Now, to solve this problem, we're going to use a little bit of logic. Firstly, however, we're just going to use our knowledge of calculus and what a stationary point represents graphically. We can see that f of x has a stationary point at roughly x equals 1. That's because the gradient of the tangent is roughly flat. So this means if we take f prime, which is the derivative function, of 1, we'll get 0. To proceed further, we're going to have to use the chain rule. So firstly, I'm just going to write out h of x again. h of x equals f of g of x. Now what we're going to do is we're going to differentiate h with respect to x. So here's when we're going to use the chain rule. So we're going to write h prime of x equals, so it's the derivative of the inside, okay, which is g of x. So that'll be g prime of x. That's going to be times the derivative of the original function, like such. So this expression here is the derivative of h of x. Now we know that a stationary point occurs when the derivative is equal to 0. So in order to have h prime of x equals 0, we can have two cases. We can have g prime of x equals 0, or f prime of g of x equals 0. For g of x, this is quite easy to see. We just look at our graph and we see that at x equals 3, we have a stationary point. Okay, so this is the part where it gets a little bit tricky. We want to know when f prime of g of x equals to 0. In order to do this, let's look at when f prime of x equals 0. So we can solve our graph and we see here, f prime of 1, roughly, equals 0. So that means if we can have this thing here, inside the f prime, which is 1, equal to g of x, we will have a stationary point. So we look at our graph and let's draw a line at y equals 1, and we can see that we have 2 points of intersection. So that means g of x equals 1 twice. And both of these points occur within x equals 1 and x equals 5. So that means from this condition here, which is f prime of g of x, we get 2 stationary points. If we then add these two conditions together, we see that we get in total 3 stationary points. Alright, now that we've finished the multiple choice, we're ready to move on to the short answer questions. So firstly, question 11. We're told that there are 2 tanks on a property, tank A and tank B. Initially, tank A holds 1,000 litres of water and tank B is empty. Tank A begins to lose water at a constant rate of 20 litres per minute. The volume of water in tank A is modelled by this expression, V equals 1000 minus 20T, where V is the volume in litres and T is the time in minutes from when the tank begins to lose water. On the grid below, draw the graph of this model and label it as tank A. So all we have to do is draw this line 1000 minus 20T. Instantly we see that the y-intercept is 1000, so we can put a point here. If I just rewrite this, V equals 1000 minus 20T, and I try and solve to see when this is equal to 0, what I can do is I can divide everything by 20. This will give me 50 minus T equals 0, which means that at T equals 50, we have no water left. So I can draw the line, straight line using a ruler, connecting these 2 points, like so. And that's part A. Okay, now for part B. To do this question, we have 2 different options. We can either do this an algebraic way, or we can do this a graphic way. Now, we have the same proposition for question C, so what I'm going to do here is I'll solve this the graphical way, and then part C I'll do the algebraic way. So firstly, let's just take the key bits of information about tank B. We're told that it starts filling at T equals 15, and it has a constant rate of 30 litres per minute. What this represents graphically is our x-intercept and our gradient. So let's go back to our graph. So we'll draw this one in green, and we know it starts at T equals 15. So as we're told this tank B fills up at a rate of 30 litres per minute, we can calculate how much water there should be after, say, 10 minutes. So after 10 minutes, we should have 10 times 30, which equals 300 litres. So we go from T equals 15, we go across 10, we go to 25, and we have 300 litres. So let's go up here, and let's draw in our point. And we know that to draw a straight line, all we need is 2 points. So we just connect them, and we get our somewhat straight line. The question asked us at what time the 2 tanks have the same volume, so all we do is we find the point of intersection, which is here, and if we just go down, we see that that happens here at 29 minutes. So we go back to our answer, and we say T equals 29 minutes. So now for part C, I'll use the algebraic method in order to solve this. What we're actually solving is VA plus VB equals 1000. So we actually need to find an expression for VB. First of all, we know 2 points on VB. We know the first one is 15, 0, and we know the second one, which we drew in, is 25, 300. So we can find the gradient, which would be 300 minus 0 over 25 minus 15, which equals 30. So we can write our line as VB, which is the y parameter if you'd like, minus 0 equals 30 inside of t minus 15. means VB equals 30t minus 450. So now what we want to do is we want to find VA plus VB equals 1000, and we know that VA is equal to 1000 minus 20t. So we can say 1000 minus 20t plus 30t minus 450 equals 1000. We have 1000 on both sides, so we can cross those out. We can then say 10t minus 450 equals 0. If we divide by 10, we get t minus 45 equals 0, so therefore t equals 45 minutes. Okay, our next question, which is question 12, is our first introduction to series for this paper. I've included the formulas over here on the right, and mainly the two we'll be using are the ones that I'm going to highlight now. So first things first, we're going to want to find an expression which tells us the nth term of this arithmetic series. So how can we do that? Well, we can first say that this 4 here corresponds to A, our first term, and we can find the common difference by taking the second term, 10, minus the first term, 4, meaning our common difference is 6. We now have our two pieces of information in order to find the nth term formula. So we can write t of n equals A, which is 4, plus n minus 1 times 6. If we expand, we get 4 plus 6n minus 6, which is 6n minus 2. The reason we've done this is because we want to know how many terms are in our series so that we can sum it. To do this, we'll consider the last term, 1354. We know that's in the series, so we can say 1354 equals 6n minus 2, and we can solve for n. We'll get 1356 equals 6n, which means n equals to 226. Now we can use the sum formula that we've put over on the right. This means that s of 226, the number of terms, equals 226 over 2 times the first term 4 plus the last term 1354. If we put this on our calculator, we get the result that s of 226 is equal to 153,454, and that's our final answer. For question 13 here, I've included a standard integral which can be found on the integral table on the formula sheet. The reason I've done this is because it's a very straightforward integral to calculate, and it's literally given to us here. So what we say is that the integral from 0 to pi over 4 sec squared x dx is equal to tan x from 0 to pi on 4. That's just from this formula here. So all we need to do is we need to calculate tan pi over 4 and then subtract tan of 0. This is just equal to 1 minus 0, which is equal to 1, which is our answer. Now, question 14 gives us a nice introduction to probability for the exam. It tells us that history and geography are two of the subjects students may decide to study. For a group of 40 students, the following is known. 7 students study neither history nor geography, 20 students study history, and 18 students study geography. The question is, a student is chosen at random. By using a Venn diagram or otherwise, find the probability that the student studies both history and geography. So we are going to construct a Venn diagram for this question. Okay, so straight away, we can fill in this sort of null space, which I mean by over here, that 7 students study neither. So that's what this represents. This represents the students that study neither of the subjects. They don't fall into any of these categories. We're then told that 20 students study history. I'll just write it like this for now. And that 18 students study geography. If we then sum all these together, we get 20 plus 18 plus 7, which equals 45. So the technique now is to realize that we were told there were 40 students. However, we have calculated that there are 45. Now, the excess actually represents the students who study both. So, on our diagram, we can fill in that 45 minus 40, which is 5, is the amount of students who study both. So that's the intersection of both history and geography. If we want to see how many students then solely study history, we say 20 minus 5 equals 15. We put that there. And for geography, we say 18 minus 5 equals 13. If we then add all these numbers together, we get 15 plus 5, 20, plus 13, 33, plus 7, 40. So we have a valid Venn diagram. If we want to know the probability that a student studies both history and geography, we fall into this category over here. So what we can do is you can just write P equals 5 divided by 40, which is 1/8, which is our answer. Now for part B, we are told that a student is chosen at random. Given that the student studies geography, what is the probability that the student does not study history? So what we can do is we consult how many students study geography. If we look here, we get this oval. So we have 18 students as 18 students. If we then look, we can see that 5 of those do history. This means 13 do not. So, the probability that a student does not study history, which we write as H, the little bar meaning the complement of H, given that they study geography, is equal to 13, which is how many don't, divided by the total geography students, 18. And that's our answer. Now finally for part C, we're told 2 different students are chosen at random, one after the other. What is the probability that the first student studies history and that the second student does not study history? So firstly, we consult all 40 students, and we can see that out of the 40, 15 plus 5, which is 20, study history. So for the first student, I'll write P1. We're going to have 20 total out of 40 possible, which is a half. And now for the second student, we must bring the size of our sample space down to 39. That's because we initially had 40 and we took out student 1, so we now have 39. So I'll just write here there are 39 students. And as we said, there were 20 out of 40 who studied history, and we took 1 out. That means we now have 19 students who are studying history out of the 39. So that means out of 39, the amount of students who do not study history, which I write as follows, is equal to 39 minus 19, which is 20. So the probability for the second student not studying history is equal to 20 over 39. We now have to combine these probabilities, as we are told in the question and. Typically for probability questions, when we see the word and, it means multiply. So we'll take P, which is the whole probability, as 1/2 times 20 over 39, which equals 10 over 39, which is our final answer. Question 15 now introduces a bit of trigonometry. It says that Mr. Ali, Miss Brown, and a group of students were camping at the site located at P. Mr. Ali walked with some of the students on a bearing of 35 degrees for 7 kilometers to location A. Miss Brown, with the rest of the students, walked on a bearing of 100 degrees for 9 kilometers to location B. And we're asked to show that the angle APB, which is this one, is 65 degrees. So the way we're going to do this is we're going to say, well, the angle that Mr. Ali walked on was 35 degrees. And we also know that the angle that Miss Brown walked on was 100 degrees. So we know that the interior angle, which I'll draw in red here, and I'll call Z, is going to be Z equals 100 degrees minus 35 degrees, which equals 65 degrees, which is what we're asked to show. Okay, to now find the distance AB, which I'll just draw in here, we're going to have to use the cosine rule, which nicely is on the formulas over here. So we're going to call the distance AB x, and we're going to say that x squared equals a squared, which is 7 squared, plus b squared, which is 9 squared, minus 2 times 7 times 9 times the cosine of 65 degrees. Now on the calculator we can compute this, making sure that we're in degrees mode, as we don't want to make any silly errors like that. And we can see that x squared is roughly 76.75. Now, without retyping this, we're just going to take the square root of the answer, and we'll see that x equals 8.76 kilometers, which means that the distance AB, which we defined as x, is 8.76 kilometers. And that's the answer. Okay, so for question C, we're asked to find the bearing of Mrs. Brown's group, which is point B, from Mr. Ali's group, point A. And we want to give the answer to the nearest degree. So what we could do is we can draw a compass rose up here at A. The reason I do this is that we can see clearly that the angle we're looking for is this one here, and we're going to call this theta. Okay, if we just fill in a few angles here, we can say that this will be 35 degrees. We're told that in the question, which also means that this, which I won't write in but I'll keep as red, is also 35 degrees. So whilst this is getting a little bit messy, we're going to now try and find this angle here, which we're going to denote alpha. To do this, we're going to use another one of the formulas down here, namely the sine rule. So what we can say is that 9 over sine alpha is going to equal x, which is 8.76, which we calculated in the last question, over sine 65. So this means if we just rearrange sine alpha, it's going to equal 9 sine 65 degrees over 8.76. Which means that alpha is going to be inverse sine of this thing. And let's go over to our calculator to see what this is. So if we just store this value in here, we can just take inverse sine of 9 sine 65 over the answer. We want to keep it as exact as we can. And we see that it is alpha 68.6 degrees. Okay, so we're almost done now. So we can see that alpha is 68.6 degrees, which means that this little part in here is going to be alpha minus 35 degrees, which equals 68.6 minus 35 degrees, which equals 33.6 degrees. If I just clear some of this so it's a lot easier to see, we can now determine is that theta plus 33.6 degrees equals 180 degrees. That's because we have a straight line here, which means that theta was 180 degrees minus 33.6, which is equal to 146.4 degrees. So if we then go down here, we can say that theta, which is the bearing, equals 146 degrees as we're asked to the nearest degree. Question 16 asks us now to sketch the curve y equals minus x cubed plus 3x squared minus 1, labelling the stationary points and the point of inflection. Okay, and we don't have to find the intercepts of this curve. The first thing we'll do, I'll just write this out again, y equals minus x cubed plus 3x squared minus 1. We're then going to find the first derivative, so we'll say minus 3x squared plus 6, and we can factorize this as 3x minus x plus 2. We'll take the second derivative, and that'll just be minus 6x plus 6, which we can factor as minus x plus 1. The reason I've done this factorization is so we can clearly see where the first derivative and the second derivative are equal to 0. So if we look y dash equals 0, we can see that it's either going to be at x equals 0 or x equals 2. So we have x equals 0 or x equals to 2. What we can do is we can do the second derivative test, which is testing the concavity of our function. So we can say, well, y double prime at 0 equals minus 6 times 0 plus 6, which equals 6. And what this means graphically is that our concavity looks something like this. It's going up. So what we're going to have is a minimum. As you can see here, we're going to reach a low point and then we're going to come back up. So we can say, therefore, at x equals 0, min. and then y double prime of 2, well, that's going to equal minus 6 times 2 plus 6, which equals minus 6. If we look at this graphically, we're going to have something looking like this, which means we're going to have a max. So we can say at x equals 2 max. Now for the second derivative, we can say that y double prime equals 0 when x equals 1. In order to confirm that this is a point of inflection, what we do is we're going to draw a little table up. Here we'll have x, y double prime, and the concavity. And we're just going to consider what happens near x equals 1, such as at 0.9 and 1.1. We know at x equals 1 we have concavity of 0, which means we just have a point if you'd like. So now we can sub 0.9 into our expression for the second derivative. So we can say 6 times 1 minus 0.9, and this is going to equal 0.6, which is positive, so it looks like this. And then if we just think about 1.1, we'll get minus 0.6. So it's looking down, which means x equals 1 is a point of inflection. Reason being, we have a distinct concavity change. All we're going to do now is we're going to find out what the y value is at all of these points. So first of all, let's consider x equals 0. We're then going to go, if we just put 0 on our calculator, we can then go minus answer cubed. This technique just helps us not to make any errors in typing in our values. Plus 3 answer squared minus 1 equals minus 1. So at x equals 1, sorry, at x equals 0 we have y equals minus 1. We're going to do the same thing for x equals 2. We'll just store 2. We'll then go minus answer cubed plus 3 answer squared minus 1 gives us 3. So at x equals 2, we're at y equals 3. If we store x equals 1, you can then go minus answer cubed plus 3 answer squared minus 1 equals 1. Okay, so we now have the 3 points. We can draw up a nice little axes here. So we mustn't forget to label our axes, x and y. It's not something you want to lose a mark on. Now if we go x equals 0, we're at y equals minus 1, so somewhere here. If we go x equals 1, we're at y equals 1, somewhere here. And then x equals 2, about here. We go up to here. So we now sketch the curve. It's going to look something like this. Okay, and here we're going to label 2, 3. Here's 1, 1. And here's 0, minus 1. And that is the curve y equals minus x cubed plus 3x squared minus 1. Okay, in order to solve question 17, we're going to have to use this standard integral, which can be found on the integral table on the formula sheet, which tells us that if we can somehow manipulate an integral such that we have the derivative of the denominator on the numerator, okay, it's just equal to the natural log of that function. Now, the most clear example is 1 over x, because the derivative of x is just 1, so this is actually the natural log of x plus constant. That's just an example. If we now look here, and we look at what our denominator is, we have, I'll just call it u, equals 4 plus x squared. If we then take the derivative, over here, u prime, we get 2x. So we almost have what we have on the top. So I'm just going to rewrite this integral. This is the little trick. So we write 1/2 times 2x over 4 plus x squared. The reason we can do this is because technically we could just cancel these out and we'd have what we started with. However, that's not going to help us. That's why we introduce the half. So what we can then do is we can bring the half outside as it's just a factor. 2x over 4 plus x squared. and we satisfy this form over here, where we have the derivative of the denominator in the numerator. So we can just say this is equal to 1/2 times the natural log of the absolute value of the denominator, which is 4 plus x squared, plus some constant. And one last thing, we can actually get rid of the absolute value signs. The reason being 4 plus x squared will always be positive. So that's our final answer. For question 18, we're asked to differentiate this expression, e to the power of 2x times 2x plus 1. What we're going to do is we're just going to let y equal e to the 2x times 2x plus 1. I'm also going to let u equal e to the 2x and v equal 2x plus 1. I'll put that in brackets. If I then take the derivative of u with respect to x, I get 2e to the 2x. If I take the derivative of v with respect to x, I get 2. And if I use the product rule, I will then say that y prime is equal to v times u prime. So v 2x plus 1 times u prime 2e to the 2x plus u e to the 2x times v prime 2. And then what I can do, I'll just write this like this. 2x plus 1 plus 2e to the 2x. I can then factor out the 2e to the 2x such that I'm left with 2x plus 1 and then plus 1 from this expression. I'll then get 2e to the 2x, 2x plus 2, and you can see here we have a common factor of 2 which we can factor out. So this is 2 times 2e to the 2x, x plus 1, which equals 4e to the 2x, x plus 1, which is our final answer. So now we're going to apply a similar trick as we did in question 17 to find the result of this integral. Typically, to calculate something like this, we'd need to use techniques in Extension 2 Maths. However, we can use a little trick here. The trick, once again, is to say that this thing is equal to the integral of 1/4 times 4 e to the 2x, x plus 1 dx. The reason we do this is because up here we found that 4e to the 2x times x plus 1 was the derivative of e to the 2x times 2x plus 1. So if something is the derivative of another function, if we then integrate the derivative, we get the function we started with. That's the fundamental theorem of calculus, or the first one at least. So what we have down here is 1/4 times the thing we started with. Once again, I'll repeat, the reason that is that this is the derivative of the thing we started with, and if we integrate a derivative, we get the original function. So we can write this as so, and we mustn't forget the plus c. And that is our final answer. Now question 19. This is our only trigonometric identity proof for the exam, and it's worth 2 marks. So what we're going to do is we're going to say left hand side equals sec theta minus cos theta. And I'm going to try and show that this is equal to the right hand side, which is sine theta tan theta. First thing we'll do is we'll write sec as 1/cos, and then we'll combine this and make one fraction. So what we do is we'll keep this as such, and we'll times cos theta by cos theta. So we get 1 minus cos squared theta over cos theta. And we know what that is from the trigonometric identity. Sine squared theta is cos squared theta equals 1. So that means the top is sine squared theta and then over cos theta. And we're going to now write this as sine theta times sine theta over cos theta. And sine theta over cos theta is just tan theta by definition. So that is our final answer, as it's equal to the right hand side. So we've proven this to be true. Okay, so the final question of this video, question 20, is asking us to use the trapezoidal rule, which I've included over here. It's straight from the formula sheet. I'm now just going to draw a little graph which doesn't necessarily represent exactly what we've got here, but it'll serve a purpose which we'll see. Let's imagine that our function looks something like this. Okay, if we consider this point over here to be our ending point, which is 5/60, and this point here to be 0, which is our starting point, we can then split up the graph according to these points here. So 1/60, 2/60, etc. So here will be 1/60, roughly. This will be 2/60, say, 3/60, and 4/60. Now the reason I've done this is that we can count how many pieces, if you'd like, or how many areas we want to calculate. So we've got 1, 2, 3, 4, and 5. Now this actually corresponds to n here in our trapezoidal rule formula. So we can just note that n equals to 5. Now also in the formula, b is given as the final x value, if you like, or the final horizontal value. So here, we'll just write b, which is 5/60, and a is the starting one, which is 0. Now by the same principle, that means this will be f of a, and this will be f of b. So f of a is 60, f of b is 67. So now we're just going to go down to our formula, and we're going to say that the integral from 5/60 to 0 of t dt is roughly equal to, so b, which is 5/60, minus a, which is 0, over 2 times 5 times by 60 plus 67 plus 2 times 55 plus 65 plus 68 plus 70. I'll just simplify this a little bit, so when we put in the calculator, this is roughly equal to, well, we can actually cancel these 5s, okay, and we'll actually have 1/60 over 2, which is 1/120, outside of 127 plus 2 times 259. And now we can go over to our calculator, and we're just going to calculate this. And we get out, this is roughly equal to 5.375 kilometers, but we want the answer to one decimal place, so this is equal to 5.4 kilometers. And that is our final answer for question 20.